That's the page I'm on, my friends. I don't have a test or quiz plan for you this week. Sorry about that. Friday, I'm hoping to talk to you. I want to build. Now we talked to you a little bit about how credit card can be bad, but I want to kind of take us through like the day in the life of a early 20-something-year-old person, and kind of show you how your 20s are a really good time, but it's also a time that you could put yourself in debt for a really long time. So I'm not saying don't do it. I'm just saying the more you know, the more informed decisions that you might be able to make. All right. So did you find some?
Yes.
Beautiful. So let's go back before I get to what the lesson is. Do you remember we talked about this? Which basically this could be a function b and y equals x to the third. And we're not worried about it. But I think you might have recalled where if we took the derivative of something so simple, it got to that. Agree? So let's talk about this graph. We'll do this, maybe do it in a red. So there's something that's taken place up to about this point here. And then from here to here, there's something else taking place. So using very basic terminology, as I go to the right, so from my board to me, because I'm standing to the right of the board, what is the red doing in the y direction? The y is the vertical direction. It's increasing, right? Does everyone feel comfortable with that? And then what is taking place with this green part? Hopefully you can see the difference between green and red. If not, I'll change color for you. What's taking place there? It's decreasing. Okay, so the red here and here is increasing, and the green right here, green right here is decreasing, which means that if I were to take, let's say I had the xy axis like this. If I were to take the values between here and here, these values in between, the derivative, which finds me the slope, so this finds me the slope at a point. That means that the slopes all the way through here would be negative slope, whereas the slopes here would be a positive slope. And then the slopes that take place right at here and here, those blue, the slopes at the exact spot would be 0 if you plug those values in. Okay? So if you recall, the derivative, if you wanted to find the instantaneous slope at any particular region, which finds you the linear equation that would be tangent to that line anywhere it goes, and that linear equation kind of changes as you go throughout the whole graph. There are certain things that take place. So you have positive slopes, you have negative slopes, you have 0 slopes. You even have undefined slopes that would be if it was a vertical line. Now let's take this a little bit further. Let's say we had some obscure looking graph that did this. Okay? Now let's make this a little bit better. Let's make it like this. So there's something that's happening right here, and there's something that's happening right here. So what's basically taking place is I have a positive slope here, and I have a positive slope here, and then I drop down to a negative slope over here. But notice this. This region here, our slope is equal to 0, and this right here, our slope is equal to 0. But we go from going positive to 0 to going positive to 0 to going negative as far as the slope goes. Does that information make sense? So a lot of times what we'll do, and this will take us back to our notebook, is we're going to take that exact same idea, and we have this silly little graph that they have drawn up here. And this graph does not This graph doesn't have any numbers. It just has letters. So let me ask you this. Exactly at point A, would you think the slope's negative, positive, or 0? At point A. Negative? At point C, negative, positive, or 0? Point C. What do you think? So you agree this is a negative slope here. This should be a positive slope here. This should be a positive slope here. And this one has a negative slope here. Does that make sense? And so that means that B, D, and F, the slope is not positive or negative. I'm going to have a 0 slope exactly here. I'll have a 0 slope exactly here. And I'll have a 0 slope exactly here. Meaning I would have had to have known what the equation is, taken the derivative, taken the x value at that exact point, plugged it into my derivative. If it came out to 0, it would have found you the B, the D, or the F points if you were to pick the anywhere between to the left of B. So that would include the whole A region. If I were to take the derivative and I were to plug any one of those points in right here, let's see, let's draw here. If I were to plug in any of these points here, anywhere along that yellow is going to give me a negative slope. Anywhere along this yellow here is going to give me a negative slope. And then let's change the color of this because we can. So this is taking place, and then this is taking place. So anywhere along here, those would be positive and positive, whereas the others at the turning points or this weird little area here, this is going to take me to these 0 slopes. So meaning if I knew what the function was mathematically, I took the derivative and I plugged in whatever the B value would be, or if I plugged in whatever the x value of the D value point would be, or if I plugged in the x value of the F value into the derivative, my answer would be 0. If I plugged anything along this yellow, any x value along this yellow or this yellow, if I plug any of those x values into the derivative, I'm going to get a negative slope. If I plug anything in for the blue, any x value to the derivative, I'm going to get a positive slope. Now, I don't necessarily know what the slope is. I just know that it would be positive or negative. So that's kind of what we're going to do. And so what we're going to do is we're going to generate something called the F prime chart. And so there's values that you want to list, and you're going to say, hey, at point B, at point D, and at point F, those are basically where my slope of my derivative would be equal to 0. And so I would have a negative component here, a positive component here, a positive component here, and a negative component here. So there's something that happens at point D. Point D is called a point of inflection. And a point of inflection is where you are either going up in the positive direction and you flatten out and then you keep going up, or you're going down in the negative direction, you flatten out for a moment and then you continue negative, and it's going to tell you that. So if I had just this given to me, if this was the only thing that was given to me, and we would probably have numbers for B, D, and F, but if I wanted to kind of draw myself, if I didn't see my actual picture, I would label B, D, and F, and I could say, well, what does this graph look like? If I couldn't see the original graph, things that you can say is like, hey, I'm coming down here, and then something's going to happen here where I'm going to kind of go up, I'm going to flatten out, and I'm going to keep going up, and then I'm going to get to F, and then I'm going to start going down again. So this graph doesn't look exactly like this, but it gives us an idea of what our graph could look like based on the F prime chart. So let's move down a little further and see what takes place. Or let me pause for a minute. Is there any questions so far about what we're talking about? Hello. Good to see you. Let's make our F prime chart based on what we have labeled. So what should I label on the horizontal line to the right? What letters should I have indicated? Or what numbers? Let's go with numbers because we have X values. Any thoughts? Yeah, -1, 1, and 4. Perfect. So what is the slope here? Positive or negative? That blue region, what's the slope? It's positive. What is the slope here? This next region. Negative. What is the slope here? And then what is the slope here? So you've just created a sine graph or sine chart based on what the graph is doing. And in the world of calculus, a lot of times they will give you basically a sine chart here, and things that you need to know about this is I need to know, oh, I went from positive to negative. So if I went from a positive to a negative, that means at -1, this would be something called a local maximum. Do you feel that this would be a maximum point? I came up to then go down. So A would be what is called a local max. As I come down to this region, because the signs change, if I go from a negative to a positive, that means that +1 is going to be a local minimum point. And then what's going to take place here at C, because it went from positive to positive, this means it's a point of inflection. Okay? Now, points of inflection do indeed exist. So I'm going to say that this is a max, this is a min, and this is a point of inflection, or a POI. Okay? Now, points of inflection can indeed be found using derivatives. We don't necessarily jump into these as much, but basically, a few things will happen with a derivative. A derivative, if you set that derivative equal to 0, it's going to find you local mins and local maxes. If you take the second derivative of a function, then, and you set that equal to 0, that will find you where a point of inflection takes place. So it's like, Stirrup, you had us at derivative, now you're telling me there's a second derivative, and the answer is yes. So if I came back to this, and if I just had, let's go with our simplest equation. If I said, okay, what's the derivative of x to the third? And it's 3x squared. And then if I just took over to the side and went, okay, 3x squared is equal to 0, divide by 3, x squared is equal to 0, root. So at 0, this is either a max or a min. But then if I said, okay, I want to take the second derivative, so I'm taking the derivative of this, that's going to give me 6x. And so then I said, okay, well, if I go 6x is equal to 0, x is equal to 0, if I solve that, this is also going to give us a point of inflection, which seems kind of weird. And it doesn't necessarily translate as nicely with a, such a basic parent function of x to the third, but this is how the second derivative works. So there's two things that basically happen here. We have a max min, and then we have a point of inflection, all of the same thing. But let's take, if we had, let's go a little bit further. If I took the derivative of this, I'm going to get 3x squared plus 2x plus 1. And if you set this equal to 0, and I'm not going to ask you to factor that or use Desmos, if I set those equal to 0, this is going to find me my maxes or my mins. And if I took the second derivative of that, I'm going to get this. And I set this equal to 0, this is going to find me my point of inflection. Now, it is possible a point of inflection does not exist on a graph. So those are just a few things that kind of take place, and I'm going to go over how we would determine if a point of inflection truly did take place or if it didn't based on the equation. Let's go back to our stuff. Okay, so we want to take a look at this first one. So I want to plot the points 1, 3, and 5. So if I go from a positive to a negative, if I go from a positive slope to a negative slope, this would be a maximum. Okay, that's going from positive to negative. And then it goes from negative to more negative. Something takes place here, like a little wiggle. So this is indicating there's a point of inflection because these signs are the same. And then if I go from up to start doing this, if I can make my graph right, we go to a positive slope. So I have a negative slope here, a negative slope here. Point of inflection is taking place there. So anytime you have two identical signs right in a row on that, that means a point of inflection is taking place. It means your graph had done a flattening out. It changed its pitch or its direction a little bit. It goes from negative to more negative or negative to not as negative. So those are things that take place. If I look at this graph, I'll say, okay, I have -3 here, I have 1 here, and I have 4 here. Hey, friends, where's the point of inflection going to take place based on our example 2? Where do you think the point of inflection takes place? The point of inflection took place with negative. Where's the point of inflection going to take place on this one? Someone's getting a lot of emails. Here's my... So this is a point of inflection. Where's my point of inflection taking place on this? Yeah, right here. Okay, so you might recall from Algebra 1, right, or from Algebra 2 even. Do you remember the term that was used, bounce, wiggle, cross? Okay, point of inflection is the wiggle. Okay, point of inflection is the wiggle on if you use bounce, wiggle, cross. Okay, so you've been seeing point of inflection. It hasn't always been called that. All right. So, well, hi.
Hello.
I missed you.
Miss you too.
We are 5.1. Thank you.
Okay. I like don't have my Blackberry.
All right. So, let's jump through this problem. I think this is the last example I give. All right. So, the first thing we want to do is find the roots. So, that says set this equal to 0 and solve. Okay? So algebraically, you could say, oh, I could factor an x out, and I'm going to get x squared minus 12 equals 0. We'll set each of those parts equal to 0. Bless you. Root, don't forget the plus minus. So root 12 breaks down to 2 root 3. Okay, so these are the roots. I have a root at 0. I have one at 2 root 3. And I have another one at -2 root 3. Okay? So those are our roots. And then, without using a calculator, we want to know where this is increasing or decreasing. Intervals that it's increasing. So from the left of -2 root 3 to up till from -2 root 3 to 0, from 0 to 2 root 3, and to the right of 2 root 3. What is taking place? We want to find max and mins as well. So we're going to talk. Okay, so the best way to do this is pick a value to the left. Okay, so if I pick a value to the left, that's a simple value to use. I'm going to pick some value out here. So maybe I take negative 10. Negative 10 is way over here. Agree? So if I take negative 10 and plug it in, I basically get negative 1,000 plus 120. Negative 1,000 plus 120 is positive or negative? Anybody? Negative 1,000 plus 120, positive or negative? Negative. So over here, we have a value that's decreasing. Okay? So then I have to kind of pick a value between 0 and negative 2 root 3. So a value that might work real easily might be negative 1, which is like right here. If I take negative 1 and plug it in, I'm going to get negative 1 plus 12. So if I plug negative 1 in, negative, negative, negative is negative. So negative 1 and then negative 12 times negative 1 is positive 12. Negative 1 plus 12, is that positive or negative? Negative 1 plus positive 12, positive or negative? Okay, that's positive. So then I want to pick a value that is in between 0 and 2 root 3, which would be like 1. So if I take 1 and plug it in, I'm going to get 1 times 1 times 1, which is 1. 1 minus 12 is negative 12. 1 minus negative 12, positive or negative? Negative. And then if I pick a value that's to the right of 2 root 3, so if I pick 10 and plug it in, 10 times 10 times 10 is 1,000 minus 120. 1,000 minus 120 is positive or negative? Positive. Okay, so that basically means something is taking place with this. So if I go from a negative to a positive, that means I'm going a negative to a positive. This creates a min. If I go a positive to a negative, so if I go like this, that creates a max. So we want to see where this graph is increasing, the interval where it's increasing, and where it's decreasing. Well, it's increasing. It's increasing. If this is a min from a negative to a positive, from a positive to a negative, this right here is indicating that a max is taking place. So where is it increasing? So it's increasing up until 0. So here it's increasing. So negative to positive, and then negative to positive. It's also increasing here. So this is going out to infinity. So the places where this is increasing is from negative 2 root 3 up until 0. That's creating an increasing part of my graph. And then from 2 root 3 to infinity, it's also increasing. Where is it decreasing? It's decreasing here. So from negative infinity to negative 2 root 3. And it's also decreasing here. So that's from 0 to 2 root 3. So you're using the x interval to say where the graph is increasing or positive to where it's decreasing, which is decreasing or a negative slope. And then where does the max and min take place? Well, the min takes place where it goes from positive to negative, or negative to positive. So we're going to get a min here, and we're going to get a max here. So if you wanted to try and convey what this graph is going to look like, this graph is going to kind of do something like this. So it's going to look like a W in some form. Okay, I don't know the exact parameters of the graph. It's just going to do something that looks like this. That's what our graph itself is going to look like. So I want to give you the opportunity to take a look at some of these. And would you try 1, 2, and 3 before you leave? And we'll call that good for tomorrow. We'll go over those tomorrow. 1, 2, and 3 on worksheet 5.1. Thank you.